Okay, today we're going to review rational exponents to get ready for our quiz on rational exponents and higher order radicals. So pause the video and try the warm-up. Okay, so if I want to write the expression in its simplest form, the first thing I want to do is, because these are not the same radicals, this is a cube root, this is a square root, and because the bases aren't the same, this is x squared and this is x, is I want to rewrite it using powers. So I'm going to write this as x to the 2/3 times x to the 1/2. Now I have like bases, and to simplify this, because I'm multiplying, I'm going to add the powers, which is going to require me to create common denominators. So this is really like 2/6 plus 3/6 gives me 7/6. Number 12, because I have a power raised to another power, I'm going to multiply my powers, and 2/3 times 3/4 is 2/4. But 2/4 reduces to 1/2. Number 13, I have the cube root of 81. So I'm going to break that down to 9 and 9, which I'm going to break down to 3, 3, 3, and 3. Here's my perfect cube. It's going to come outside. This little 3 I'm going to hold on to, it's going to stay inside the radical. I'm going to move on to my variables. I have x to the 5th. If you like to do it this way, do it this way. That comes out. These are going to stay inside. Another way, of course, is to say 5 divided by 3 divides 1 time with 2 left over. The cube root of y to the 3rd is just y. And then I'm going to keep my 3x squared inside because they are not perfect cubes. The last problem, all I'm going to do is subtract the powers because it's division. I just need to be careful because I have some fractions. I have 2/3 minus -2, which becomes plus. I'm going to put 2 over 1, multiply it by 3 over 3. This becomes 6/3. 2 plus 6/3 is going to be 8/3. I have y to the 1st minus 3/4. I'm going to think about my 1 as 4/4. So it's going to be x to the 8/3, y to the 1/4. All right. Here are the answers to the bookwork from last night. Pause the video and check your homework. Okay. Here are the answers to making skills practice. I don't remember what the number was. All right, let's do 3 of the more difficult problems from this assignment. Let's do 40, 45, and 49. Again, you can always rewind to go back and look at your answers. All right, number 40 is the cube root of 48, c to the 3rd, d to the 8th, divided by 2 cube root of 6d squared. Because these are both cube roots, I can divide. So I'm going to keep that 1 over 2. I don't want to forget that that's 1/2. And now I've got the cube root. Well, 48 divided by 6 is 8. And I have no c, so it's just going to be c to the 3rd. 8 minus 2 is d to the 6th. Now what's really awesome about this problem is once I divide what's under my cube roots, I have a perfect cube here. The cube root of 8 is 2. The cube root of c cubed is c. The cube root of d to the 6 is d squared. This is all over 2. So the 2's cancel, and I'm just left with cd squared. Yep. All right, let's look at 45. 45 is 6 times the cube root of 16 minus 2 times the cube root of 54. Well, I'm going to reduce the cube root of 16 by thinking about it as 8 times 2. The cube root of 8 is 2. This 2 is just going to stay inside the cube root. So this is going to become 12 cube root of 2. Now, 54 is like 27 times 2. The cube root of 27 is 3, so I have minus 2 times 3, cube root of 2. which becomes 6 cube root of 2. So now I just treat these like terms. I have 12 cube roots of 2 minus 6 cube roots of 2 means 12 minus 6 is 6 cube roots of 2. All right, let's take a look at 49. All right, 49. Before I write it down, I notice that it's x to the 4th minus x squared. So I'm going to take out the greatest common factor of x squared. The second radical does not have a greatest common factor, so I'm just going to leave it. I look at 49, and I see I have this x squared under the square root, and the square root of x squared is just x, so it comes out. And now I have like radicals. Now this is a little weird. These are my like radicals. These are my coefficients. I can't really add my coefficients together, so what I'm going to do is just kind of group them as x minus 1 times the square root of x squared minus 1. Do not go to math jail. Don't take the square root of x squared minus 1 and make it x minus 1 by taking the square root. You will go to math jail. It will be bad. Little person with a stick who's going to beat you. Don't take the square root. If you were to factor this for fun, because I know that's what you all like to do in your spare time, they're not the same. You cannot take the square root of them if they are not the same and can be written as a quantity squared. What I'd like you to do is to now, if you need to, pause the video and look at these answers, please pause the video and look at these answers further. What I want you to do is I want you to start making practice fun 39. Pause the video. When you unpause the video, I'll have the answers up on the board for you.